In this third and last video, we will move on to the implementation of reward by risk in a recommender system ranking. So, the framework that is often used in industrial recommender systems is also described in this multitask fusion paper in this in our GitHub repository, which says that the ranking model is actually an estimator model, which outputs a multitask estimates of multiple tasks. And then there's this fusion layer, so to speak, which combines these estimates into one composite value and one score, if you will, that roughly correlates with the value to the user, the long-term value to the user. I recommend looking at this paper. Among other, there's the part that that resonated very well with me is this section here, which is, however, all the above methods still focus on optimizing instant user satisfaction in a greedy way, but ignore long-term user satisfaction. In this paper, it talks about offline reinforcement learning, batch reinforcement learning, etc. It's a good thing to look at. But let's come back. Right now, I'm referencing this paper primarily to say that in modern recommender systems, we have a number of candidates, come up with estimates of it, and then we specify in a configuration how to combine them into a score. Okay, so so let's look at an approach to do so. Sorry, trying to get this out. This is like the example we are using here is, let's say, of a video recommender system. Again, they should work in all recommender systems, but the assumption I'm making is the user attention is on one item. If your recommender system UI is designed so that the user attention is on many items, like, I don't know, 10 items at a time, then it's hard to attribute to the probabilities for each item. That's why some of the things we discuss here is easier or more applicable to a UI where the user attention is on one item at a time. And that's why I use full screen video recommender systems like you see in TikTok, YouTube Shorts, or Instagram Reels, etc. So, so this is just like a JSON config of describing how to maximize my reward. This just says that, hey, in this case, the ranking value is nothing but the probability of watching the video as emitted by your MTML system multiplied by 1. So it's just purely saying that let's assume that the baseline here ranks your candidate videos by the probability that the user will watch them. So the baseline here is ranking your candidates by an expectation of reward. Right? Reward in this case is the probability of watching the video. So we are ranking candidates by an expectation of reward. Now, the next thing we can do is the reward is achieved only after they graduate and they don't skip the video. Let's say skip is defined by, they didn't even watch, I don't know, 5 seconds of it. So in this case, non-skip is that they moved beyond 5 seconds. So in this case, what we are saying is an improvement could be the sort of conditional probability of reaching the second level of reward multiplied by the probability of crossing the first level of reward. Here we are saying that let's rank our candidates by probability of watching the video multiplied by the probability that they did not skip it. The reason we are going into this is because there are two ways of implementing or accounting for skips. One is multiplicative, like here, probability of watching the video multiplied by non-skip, and later we'll see the one by skip option, and that'll be closer to our implementation of reward by risk. But I recommend, this is also totally logical, conditional, conditional event specification, and then multiplying a more composite event by the probability of the earlier event. This has been known to work. And you should give this a shot. Okay. So non-skip conditional changes this to probability of watch multiplied by probability of 1 minus skip. Then the inverse skip formulation actually tries to start formulating in the reward by risk framework. And what this does is it defines an inverse skip by 1 by skip. This max 0.1 just makes sure that you are that when the estimate of skipping is very low, I don't know, let's say 0.001 or 0.01 or something, then it could affect your ranking too much, and you're providing some sort of a threshold below which you don't want there'll be some error in your prediction, right? And you don't want to be overexposed to that error. So this is why max 0.1. But if you don't want to go into that, you can just say that here we are ranking by the probability of watching the video multiplied by 1 by the probability of skipping it. That's what I've written here. Inverse skip illustrates the reward by risk advice of this block and ranks by p watch by p skip. Inverse exit is similar to 1 by skip, except instead of p skip, it uses p exit. Now, which is better? And I have a point of view here, but again, I think this is very domain dependent. If you do have both of these actions, if your domain is such that p exit is really low, I don't know, like 1% or something, that means it's not a very significant risk. Like that you should not give it so much importance, basically. So but on the other hand, if p exit is high, and that typically tends to be high at the top position, so it's also a position dependent statement. But if p exit is high, that's more directly like establishes, like exit is the event that actually shows you that the user will not get value in future. After skip, they could potentially get value, and a lot of value, if they suddenly find a good video and they are watching a lot more of it. So whether p exit is better or p skip is better in general is depends on your application that you're trying to optimize. But the difference between these two is just whether you're using p exit or p skip. The math is the same. Separate top position is what my gut would say, and it's based on some personal experience, but some of that is proprietary, so I can't talk about it. So I can't talk about results. But my advice to you will be that when you're building a recommender system, often users are making up their mind at the top position, and that's where you are likely to see a high rate of exit from that feed. So here, if you have the ability to choose your top position separately from the rest, then at least for the top position, you should focus on reward divided by p exit. For others, it's kind of it's domain dependent. You have to test it out. You have to test it out. But my guess is for other positions, it is possible that reward by skip might be better. But yeah, these are some of the variables you should play with when you are testing out. But I recommend separate from reward. The general sentiment here is to optimize for reward by risk. Separate from this sentiment, I think it's also important to note at which positions, also which sort of users cohorts, your risk is highest. And again, if you sit back, like we are trying to get inspired from finance, right? There's a lot of similarity in finance, like the risk of losing money. There's some risk every day, but there are times like financial crisis times or pre-COVID times and stuff like that, when the risk of significant drawdown increases, right? And that is when you will see people behave differently and wisely differently. Like even the Warren Buffetts of the world are behaving differently. So we are sort of capturing the same idea that for positions or user cohorts where the risk is high, we should be aware of that and not just optimize for reward. Thanks.